Right, so the PCR is finished. I took the liberty of putting the results on a USB flash drive and I imported it onto my computer. And here is the file. Normally, when you do this, you're going to have to be very careful about checking controls and to make sure everything is in order. In this case, I don't have to do that because our software will do all that. So all I need to do now is check every color and make sure that the threshold is set correctly, and I need to make sure that the analysis settings that we recommend for this particular cycler are in place. So for this particular cycler, we recommend using fluorescence drift, so I'll just turn that on, and we recommend to not read the first 5 cycles, so I'll do that. And now all I need to do is set my thresholds. Normally you would know the value because you run this PCR and you validated it. Today I'm just going to eyeball it. It should be somewhere around here. For hex, it's going to be somewhere around here. For Texas, it's going to be somewhere around here. And for Sci5, it's going to be somewhere around there. Nothing else is needed because our software will do the rest. So the first thing I'm going to do now in order to be able to use our software is export these results. I'm going to go to Custom Export. For this particular cycler, the export settings are set them once, never have to change it again. So all I do is I hit export. And I'm going to have to go to the proper drive. I made a folder where I'm parking all this. It's called PCR demonstration, and I'm going to save it. And that's it. Next up is analyzing the exported results using our software. So the lab work is done. We have the data, and let's see how easy we can use the data to get to a decent report that we can send off to usually a vet as requested the data. So we already did the PCR data analysis part where we looked at the thresholds for the PCR reactions, and we've done the correct data analysis in the cycler software. So now we're gonna use the exported file that I just created, and we're gonna see if we can use those to get to some, let's say, results. So after you're done in the lab, right now I want to get my earlier plate back on screen. So I go to load plate, I go to the correct plate that I created earlier, and I'm going to select the flock. And here is the plate again. Everything is still empty, there's no data behind it. We created an export file, and now I'm going to just get the export file by going to get results. When we designed this software, we built in a bunch of features that help to prevent common mistakes. Here is one, and I am going to make a deliberate mistake to show you how the fail-safe works here. I'm going to do something wrong on purpose just to demonstrate that we try to help you avoid common mistakes. If I want to go straight to select a file, the software is not going to allow it. The software needs to get confirmation that you as a technician have performed a visual check on all the amplification curves to make sure that you picked out the aberrant ones. So the software needs confirmation, and you can give that by clicking this box over here. Now I have confirmed that I've done this, and the person that signs this off, his or her name, will show up on the report in the end. So there's some traceability here, which can be nice for labs that are subjected to quality systems. So let's go to select a file. Here's the file that I made earlier. It's just an export file. I'm going to open it. Depending on the assays that you used, sometimes you will need multiple export files to assign to your different PCRs. We can use the same threshold settings for all 3 different assays. And I'm just going to select the 3 assays, so all the data in the export file will be used to analyze the results for the 3 assays we have here on this plate. I'm going to click Get Result. If I were to do my normal job without explaining anything, I would be finished here. I would look at this, I would say, yeah, that looks good. I would save the results and I would go straight to reporting. In this case, I have to explain a little bit why I know everything is fine. So I am going to show you why I know everything is correct. And I'm going to explain what we're looking at. first things first, we see a bunch of assays and they look the same as earlier. They still have the same color and there's nothing wrong with them, because if the assay was invalid, the software would show it. When you're analyzing PCR results, you're doing two things. You're checking the controls that come with the PCR, and those controls will determine if the assay was valid, yes or no. And if the assay is valid, yes or no, the software will also check the individual status for every sample, because with PCR it is possible where the assay is valid, but an individual sample might be invalid. So green orbs mean everything is fine, the individual sample is fine. Red orbs, like this one, mean that there is something wrong with the sample. I did this on purpose. I selected samples in such a way that this would happen, because I wanted to demonstrate, again, another fail-safe feature in our software. Now, how do I know that the assays are valid? Because everything I told you looks fine. The only way to do that for me is to show you how an invalid assay would look. So I am going to do something that you as a technician are usually not allowed to. I'm going to edit results. Edit results are only available to heads of labs. There you have to have the correct user rights to do that. So normally this could only be done by someone with let's say, the technical responsibility in the lab. But today, for argument purposes, I am going to ruin my influenza assay. I'm going to edit the PCR results. And I am purposely going to ruin my, in this case, negative control. I could have done this with any control because the same checks apply to all the controls on the plate. But in this case, I have decided to ruin my negative control. We have reference values for all our controls. And I happen to know that for this kit, the internal control in the negative control has an upper limit of 34. So I am just going to make it 38. Last time I checked, 38 is higher than 34, so I'm expecting trouble now. And that's exactly what's happening. If the assay would have been valid and you would have opened it, this is the result you would have seen. You would see that the software gives you a pop-up screen, and it gives you the different assays here on these tabs, and it will help you to determine where the problem is. Well, in this case, you can already see on the plate that these ones are now grayed out and they have a big cross in it, meaning that that assay is invalid based on the value of the controls. According to my software, there's nothing wrong with MGMS, no errors found for this assay. I can select a different tab, which in this case is influenza, and here is my problem. In well A5, the internal control is out of range for assay influenza A. If there is a problem, the software will help you to find it. You don't have to start looking for it, because if you have to do this manually, you would have to take the insert, the reference values, and compare every single value that you have on the plate against the insert, but our software is hardwired to do that, so it saves you a lot of time. So in this case, internal control out of range. We can have a look at peers, no problem there. So let's say I'm happy with this, and this is my result. I want you to know that it's very difficult to fool our software, because people unfortunately sometimes try to do stuff they're not supposed to do. So I'm also going to show you that it's impossible to submit invalid results. Now the only way to do that is by showing you how that would look, and for that I need to save it as an invalid plate. So I'm going to do that. I'm going to leave this influenza assay invalid, and I'm going to save it. Save plate. Plate contains invalidated control values. The software recognizes that there's a problem with at least one of the assays. Do I still want to save it? Yes, a bad result is still a result, so we save it. And now it's in the database and it's under the invalid name. Normally, when you do this, you will only have one database entry while you're doing this. But now, because I have done demonstration purposes, there will be a few. Normally, you would only have one. So, the next thing that I want to show you is that it's very easy in our software to get a good look on the status of the samples and the reactivity. The green orb is already telling me that the sample is fine, but I do not know what's in it. We have a whole bunch of options in the bottom right of the screen. If I select all, which is the easiest option and the one that you will use most commonly, here in every well you can see the reactivity, which targets were positive, what the control status was. Everything you could possibly want to know is already here in the plate, which can help you to do some troubleshooting. I explained to you earlier that we had a artificially created inhibited sample in the PRRS assay, which is the one with the red orb. The sample is inhibited if the target is not present and if the internal control is either absent or too high. Well, let's see if I do the same trick again, what the status is of this one. The internal control is far too high, and that's why it's inhibited. This was not an accident. I did this on purpose, just for demonstration purposes. Normally, I'm not expecting a lot of inhibited results with biocheck PCR. So let's say I'm happy with this. I have my assay status. I'm going to leave this one invalid because I also have a valid one for MGMS, and I have a nice PRRS result.